Greetings and welcome to a series of lectures on graphs and functions. This lesson we're going to concentrate on the coordinate plane. I'm your presenter, Lynn Mann. We're specifically going to go over how to plot points in the Cartesian plane. We're going to find the distance between 2 points as well as find the midpoint of the line segment. You may have seen the Cartesian plane, but you may have not known that it has a name. This is where we start with two coordinate lines. One is going to be our x-axis, which is a horizontal line. Then we have a vertical line, which is our y-axis. Then we build a grid around it. At this point, this is the Cartesian plane. Now, the Cartesian plane has a lot of interesting attributes to it. First of all, where the x and y intercept, at this point right here, is called the origin. The Cartesian plane is also divided up by the y-axis, and the x-axis is divided up into 4 particular regions, and these regions are called the quadrants. These quadrants are named. The upper right-hand quadrant is quadrant 1, and this does go out to infinity, both upward and to the right. The next quadrant is the upper right-hand quadrant, and that's called quadrant 2. Again, although my image ends, these quadrants do not. It goes up until infinity and to the left to infinity. The next quadrant, yep, you guessed it, quadrant 3, which is the lower left-hand corner. And then quadrant 4 is in the lower right-hand corner. And the cool part about this is that these quadrants will give you some idea of what the points inside these quadrants are. Now, a point is just a combination of an x location and a y location. So let's take a peek at that. If you are in quadrant 1, both your x's and your y's are both positive, because just like a number line, from the middle point, if you go left, they're negative. If you go from the middle point right on the x-axis, it is positive. Now, since the vertical axis, the y-axis, is numbered the same, you can just think of switching the x-axis vertically, and now from the middle point upward is positive, and from the middle point downward is negative. So quadrant 1 will always have y coordinates and x coordinates that are both positive. In quadrant 2, you have negative x's and positive y's. Quadrant 3, you will have both negative x's and negative y values. And in quadrant 4, you have positive x values and negative y values. And in fact, you've probably noticed already that I always label the x first, or I've always been saying the x's are positive, then the y's are negative. Well, that's because this is what's called an ordered pair, and order matters. For you and I to talk about the same location on our Cartesian plane, the x-axis or the x value must always be listed first, and the x always controls how much right or left we go from the origin. The y value always controls the up and down position of where we are on the Cartesian plane. So you can think of it as an address. X controls right and left, y controls up and down. All right, now let's look at a few points. And let's plot these points. So I'm going to call this point A, and the point A is 2, 3. You could also read it as 2, 3. You don't have to say the comma. I kind of get in the habit of saying comma, so 2, 3. That means I go 2 units to the right, since 2 is positive, that's my x, and 3 units up. So I'm going to start at the origin. I'm going to go 2 units to the right because it's positive, but I'm not going to stop there because I have to take care of that 3 units up. And then I have my point of 2, 3. So because 2 is positive, 3 is positive, I probably should have known it was going to be in quadrant 1. Let's take another. And First of all, I want to anticipate where this point should be. Both the x value and the y value are negative, and therefore this point of -7, -4 should be down in quadrant 3 somewhere, because that's where the negative lives. Okay, from the origin, I'm going to go 7 on my x to the left because it's negative, and then 4 units down. And there's my point, -7, -4. Now, I've always taken the x first. Now, we list the x first, but I don't have to travel the x first. I can travel the y first. So let's take another point of, let's say our C point is 7/2, -2. Now, if you feel more comfortable doing the up and down first, then go for it. Let's take another point starting at the origin, and this time I'm going to go 2 units down. As long as I don't mix up the numbers and I'm going 2 units down and not 7/2 down, I'll land where I need to land. And now I'm going to move 7/2 to the right because it is positive. Now 7/2 is another way of saying 3.5. So I'm going to go 3.5 to the right, and my point is now at 7/2, -2. So this is how we plot points. Just remember the x value is always listed first, and then the y value. The x always handles the left or right depending on the sign of the value. If it is positive, you move to the right. If it is negative, you move to the left. The second coordinate is the y coordinate. If it is positive, you move up. If it is negative, you move down. Now, sometimes our variables are not just x and y. We have some other information standing in for x and y. But I will say, when it comes to dates, as in years or month, we generally will put them on the horizontal axis, the x-axis, and the other variable will be our y. It's just kind of how we do things. Additionally, we tend to put population on the vertical axis, depending on what we're comparing it to. So let's say we're looking at college freshman, sophomore, junior, then the freshman, sophomore, junior, and senior would go on the x-axis and population would go on the y-axis. It's just generally how it's done. So let's take a look at this example. We want to plot our data based on adult smokers in the United States. Our data is year, and also our second coordinate represents the percent of adult smokers that year. And why would we want to plot this data? Well, one, we would want to see maybe if there's trends going on. How do we want to plot the data? Well, let's look at it in several different ways and see which way looks best for our particular data. So the first thing I want to show you is just plotting the points itself. On the x-axis, this would be 2005, and up on our y would be 14.54. And we're going to plot these coordinates, ordered pairs, on our graph. So here's what it would look like. Year is on the x-axis. We're calling it t for time. On the y-axis, the vertical axis, we have our percent of population. That is smokers. Okay, so we see in 2005, we go up to about 14.5, 2006, a little bit above 14.5, 2007, a little bit. Then all of a sudden we have a drop. Don't know why that is, we just have a drop. 2009 back up, 2010, slight decrease, and then since 2011, we seem to be having a decrease, but a little bit of an increase. Now, that's just plotting points and kind of comparing one point from the previous point. Another way we could have done this is drawn it in bars. So from the base all the way to the point at which it stops, this is a bar graph. If you want to think of it as this point and connecting the bottom to this point, it becomes, and make it a little bit fat, that becomes a bar graph. You also here are these called bar charts. Maybe this is a way that you want to display your data. Another way of displaying data, which I think makes a lot of sense, is by doing a line graph, meaning you have your points, but then you connect your points. And the reason why you might want to do this is to see if there's any trends going on. So you kind of have an upswing, then dips down and then comes back. You can see a trend that goes on. Now, if we're looking at just 2 points on a plot, how do you know how far they are? If they were on the same line, if I had a point on the x-axis and another point on the x-axis and they were straight across from one another, then I could pretty much find that distance pretty easily. Let's say this is on a 3 and this is on a 2. I would just say, oh, 2 to get to 3 needs 1 more. Well, the distance is 1. And the same thing if they're up and down from each other, then I could just take the distance, which they are vertically from one another. The problem is when they're offset from one another. Then how do I do it? Well, if you can imagine, this distance being the hypotenuse of a triangle, right? So much up, so much away, vertically and horizontally, connecting the dots becomes a right triangle. And to find the hypotenuse of a right triangle, we have the Pythagorean theorem. A squared plus b squared equals c squared. Well, we don't have an A, B, and C in this case, but we do have point coordinates. So we're going to use our point coordinates to find the distance. So I know it looks pretty confusing, but when you look at it on an actual triangle, and I'll show you that in a second, all the parts and pieces kind of fall into place. The first part of the distance formula between 2 points is you're going to take the difference of the x coordinates, x2, the second point, minus x1 of the first point, and then you're going to square it. That's like your a square. Your y2 minus y1 is like creating the length of b squared. And to find the hypotenuse, we're going to take the square root of it. I want to find the difference between this point P and this point Q. So I can draw a right triangle to connect those two dots. Now, honestly, it does not matter if you draw it down or up. This will work. Okay, this will work. So if I want to find this length, the horizontal difference, I'm going to have to take the x2 value, in other words, the x value of the Q point, minus the x value of the P point. That will be my distance horizontally. Y2, so y of the Q point minus y of the P point will be my vertical distance. And then just making that hypotenuse of my triangle, a squared plus b squared equals c squared. So take the square root of c, I get the square root of a squared plus b squared will equal the distance. Let's find the distance between a couple of points, and I've named these point P and point Q. Point P has the location of -2, 5, and Q has the location of 3, -4. Now, in all actuality, it doesn't matter if point P is x1, y1, or if it's x2, y2. It won't matter mathematically, but because I list it first, I'm going to go ahead and say P is composed of x1 and y1. x1 is going to be -2, y1 is going to be 5. That means Q has our x2, y2 coordinates. So our x2 is going to be 3 and our y2 is -4. We're going to use all 4 of these values and plug them into our distance formula. So wherever an x2 is, I'm going to put in a 3. Wherever x1 is, I'm going to put in a -2, keeping in mind that the formula is x2 minus x1. So I've got to make sure that negative is there, and I'm just plugging in my values at first. So plugging in my values, 3, what is that? Minus negative is a positive, so 3 plus 2 is 5, and -4 minus 5 is -9. We're going to square both of those amounts. That gives us 25 and 81. Adding 25 and 81 together, we get the square root of 106. Throw that in a calculator, you get about 10.3. So the distance between point P and point Q is about 10.3 units. So if this was, I don't know, feet, we could say feet. If it was inches, we could say inches. If there are no measurement at all, then we just leave it as is, 10.3. So now let's take a look at this example. We want to show that a particular 3 points creates a right triangle. So how are we going to do that? We're going to take this in 3 steps. First of all, let's sketch it. If we can sketch our triangle, and if it aligns with our Cartesian plane, then we can pretty much say, yep, it is strictly vertical, it is strictly horizontal, and therefore we can say it's a right triangle. Now I have a gut feeling we're not going to get that in this circumstance. It's not going to align nicely to the grid. So here's what we're going to do instead. We're going to find the length of each side of the triangle, and then we're going to show that it's a right triangle by using a squared plus b squared equals c squared, because we can use a squared plus b squared equals c squared, the Pythagorean theorem, if we have a right triangle. That holds true. A squared plus b squared equals c squared. So we use that fact to prove that this indeed is a right triangle, if it is. So let's take the first step and sketch it. So sketching our 3 points and connecting our 3 points, we get something that definitely is a triangle. And it kind of looks like at point B is our 90-degree angle. But I can't be sure until we prove it using the Pythagorean theorem. So here's what I'm going to do. I'm going to figure out the length of A to B, and then I'll figure out the length of B to C, and then we'll figure out the length A to C. And then we're going to use the A squared plus B squared equals C squared to see if that is a true statement. If it is, then hey, we've got a right triangle on our hands. And C being the hypotenuse, AC would be our hypotenuse, and that would mean B indeed is the right angle, the 90-degree angle. First things first, let's figure out the length from A to B. A is 4,3, B is 1,4. So throwing it in our distance formula from A to B, we get the distance is the square root of 10. So 4 minus 1 all squared, 3 minus 4 all squared, we get 9 plus 1, which is 10. Doing the same thing from B to C, we'll get 1 minus negative 2 all squared, 4 minus negative 5 all squared. We get 9 plus 81, and that's 90. So we get the square root of 90. In other words, 3 square roots of 10. Now we want to find the distance from A to C. So A is 4,3, C is negative 2, negative 5. Throwing in the values. X1 minus X2, so that's 4, minus negative 2. Y1 minus Y2, 3 minus negative 5. We get 30, 6 plus 64 is 100, and the square root of 100 is 10. I'm going to take my A, I'm going to square it. I'm going to take my length side B and square it and see if it adds up to the square of 10. Now that we have the distance or length of each side of our triangle, let's show that indeed it is a right triangle using a squared plus b squared equals c squared. So in this case, it's going to be the distance of the length from point A to B squared. The distance from points B to C squared equals the distance from point A to C squared. Throwing in those values, we get the square root of 10 squared plus the square root of 90 squared equals 10 squared. 10 plus 90 is 100, 10 squared is 100, so both sides equal one another, meaning this is indeed a right triangle. So given our lengths, we can show that it's a right triangle. Given points, we can show that it's a right triangle. Let's take a problem that could be a little bit fun to figure out. So if you play baseball, you already may know this answer. So let's say I am a first baseman and you are a third baseman, and you're going to have to, a ball is hit to you and you have to throw it to me. How far do you have to throw it? Now the cool part about a baseball diamond is that in fact it is not a diamond shape, it is a square shape. So from home to first base is 90 feet. From first base to second is 90 feet. From second to third is 90 feet. From third to home is 90 feet. So we want to figure out how far it is from you to throw it to me. Now, if we think of our baseball diamond as points on a Cartesian plane, we'll call home plate our origin. Our first base is along our x-axis at 90 feet from the origin. C will be 90 from the origin and 90 to the right, but 90 also up. And then likewise, B is on our y-axis, and that's 90 feet up away from the origin. So we can kind of scope it out as in a Cartesian plane. Okay. We want to know how far is it from third base to first base. And if we think of either home plate or C as our third point, it does make a triangle. In fact, it makes a unilateral triangle where first to second and second to third are the same lengths. So we're looking for this distance from A to B. Good news is we're working with some zeros because remember we put it on the Cartesian plane. So to get from home plate to A was only in the x direction, and from home plate to B was only in the y direction. So we've got a few zeros that we can calculate. So ultimately the distance from A to B is going to be 90 minus 0 all squared plus 0 minus 90 all squared. That gives us 90 squared plus negative 90 squared. That gives us 2 times 90 squared. And it's approximately 127.28 feet. So not too bad because we were dealing with a few zeros. The last thing in this lesson I want to chat about is the midpoint formula. Meaning if we have 2 points, how far is the halfway point from each point? Where is that location? And we have a nice little formula about that. So if I want to go to the halfway point between two values, 2 points, then I'm going to go half the distance of the x difference and half the y difference. Well, that's just an average. So the point that's in the middle of 2 other points is going to be the average of the x's, comma, average of the y's. It actually gives us the point itself. It's kind of a nice formula. A little bit of math, x1 plus x2 divided by 2, because it's 2 points, and I'm finding the midway point of the x's. And then I'm finding the midway point of the y's, so y1 plus y2. So graphically, here's what it looks like. I have 2 points, we'll just call it P and Q, and I want to find the middle point, the midpoint. And therefore, M is the midpoint, and it's just the average of the x values, comma, average of the y values. Let's take an example. We have a line segment that runs from negative 3, 6, P, to 1, 4, Q, and we want to find the midpoint. That means we're going to add up the x values, negative 3 plus 1, and then divide by 2. And then we're going to take our y values, 6 and 4, add those up, and divide by 2. So let's throw it into our formula. Negative 3 plus 1, that's negative 2. Negative 2 divided by 2 is negative 1. 6 plus 4 is 10. 10 divided by 2 is 5. So our midpoint is negative 1, 5. Pretty straightforward, right? I like this midpoint formula. You throw in your values, you do a little itty bitty math, and you actually get the result as a point. Okay, so we've hit the end of this lesson. We were able to talk about the Cartesian plane. We found the distance formula and we found the midpoint formula. So that's it for this time. Be seeing you.